so today we're going to be looking into mole particle conversions and doing the conversions that take us from the particles of something to the moles and vice versa. So if you remember from the intro to moles, we know that 1 mole of anything is equal to 6.02 times 10 to the 23rd of that thing, whatever it is. We could be talking about pencils, we could be talking about donuts, we could be talking about grains of sand, we could be talking about atoms. Most of the time in chemistry, we're going to be talking about atoms and molecules, ions, those kinds of things. Because remember, this number is really, really big. So it doesn't make much sense to use it to count very large things or larger than microscopic things or things that are smaller like atoms or molecules. So the way we convert is using this particular conversion. So we're either going to be going from moles to particles or particles to moles. So these are just basic one-step problems. So let's say I have 5.5 moles of iron, right? If I have 5.5 moles of iron, how many particles or atoms of iron would be in that sample? Well, for that, we know that in 1 mole, there's that many particles, right? Well, if I have 5.5, I'm going to do this. So 5.5 moles, Fe, and MOL is the abbreviation for moles. And I'm going to do a conversion, right? So I'm going to put a multiplied, and diagonally down goes the same thing. So this is similar to what we were doing before. I know that in 1 mole of Fe, I have 6.02 times.
Pardon my interruption. Just a piece of information. Right now, district-wide, our internet is down. So.
Sorry, we had a little announcement there going on. So, and I know that that's 6.02 times 23rd atoms of Fe in 1 mole of Fe. So diagonally down has to be the same unit. So if this is moles of Fe have to be down here. So that, because then that cancels, the moles cancel. So I'm left with just atoms. So now I'm going to put that in my calculator. I multiply across the top. So I'm going to do 5.5 times 6.02. And for these calculators, if you see this little, there's a little EE button. So you press EE. 23, and that E does the times 10 to the for you, so you don't have to do anything else, and you get this number. So we get 2 sig figs because our original number only has 2 sig figs, so 3.3 times 10 to the 24th atoms. So that means that in 5.5 moles of iron, I have 3.3 times 10 to the 24th atoms of iron. Okay, so let's do another one. If I have 3.7 moles of water, I want to know how many molecules of water is that. Up here we were going to atoms. Fe. So in this one I'm going from moles to molecules. So it's going to be a similar process. I'm still going from moles to molecules, moles to particles. So it'll be similar to the one we did up there. So 3.7 moles H2O. Draw my little chart. Diagonally down it goes the same thing. So this is going to be moles H2O, and then Avogadro's number molecules of H2O. Okay, moles of H2O cancel. We're left with just molecules, which is what we're wanting. So now I'm going to put this in my calculator again. 3.7 times, so I multiply across the top, 6.02 times 10 to the 23rd. And again, I get 2 sig figs, so I'm going to do 2.2 times 10 to the 24th molecules of water. Okay. Now, what happens if we're going the other way? If we're given particles and we're trying to get to moles. Hopefully you already have figured this out by now, but we're going to do the opposite of what we're doing up here. We're going to divide. So if I have, let's say I have 5.9 times 10 to the 23rd molecules of O2, of oxygen. I want to know how many moles that is. How many moles of O2 is it? Okay, so I'm going to start with what's given to me. So 5.9 times 10 to the 23rd molecules O2. I'm going to put molecules of O2 down here, which would give me the Avogadro's number molecules. Because whenever I'm dealing with particles, like atoms or molecules or ions or anything, Avogadro's number is going to be paired with the particle unit. Okay, and then on top is going to be what I'm trying to get to, which is 1 mole of O2. So now molecules cancel, and in this case, if you notice, now Avogadro's number is on the bottom, the mole number is on the bottom, and therefore we're going to multiply across the top and then divide by the bottom. So 5.9 times 10 to the 23rd times 1, and then, so that's just itself, and then we're just going to divide. So we'll divide 5.9 times 10 to the 23rd divided by 6.02 times 10 to the 23rd. Okay, and so this is a little bit less than a mole, 0.98 moles of O2. Okay. And that makes sense because this number is a little bit smaller than 6.02 times 10 to the 23rd. Okay. All right, so if you're going, if you're given moles, kind of to wrap it up, if you're given moles and you're going to particles, you will multiply by Avogadro's number. If you're given particles and you're going to moles, you'll divide by Avogadro's number. Okay? So that's kind of like the shortcut way of doing it, but I still want you to do it like this as far as setting up your work. Okay? But just know that this will always be true, is moles to particles you're going to multiply, particles to moles you're going to divide. And Avogadro's number is your conversion factor. I hope this helps. Let me know if you have any questions.